This video is going to explore combined events and what that means in terms of probability. So now let's look at the probability of rolling a 6 when you roll a dice. Well, that's very simple because it's the probability of 1 in 6 because only 6 appears once. Now let's look at the probability of an even number. Well, we have the choice between 2, 4 and 6. So that gives us a probability of 3 in 6. And again then, the probability of an odd number is 1, 3 or 5. So that's going to be 3 in 6. And they both break down into 1/2. The general rule is that we say that the probability of an event E is the number of desirable outcomes over the number of total outcomes. So the total outcomes here is 15 because it's 5 red and 10 blue. And what we want is the probability of a blue. So what we say is that the probability is 10 in 15 and that breaks down into 2/3. Let's take this question for example. You're going to need to know the makeup of a deck of cards for this. But in a deck of cards, the probability of a jack is 4 because there's 4 jacks in a deck. And in our deck, there's 52. So let's write that as a probability. So the probability of a jack is 4 out of 52, or more specifically 1 in 13. Now let's look at the probability of finding a heart. Well, there's 13 hearts in a deck of cards because there's 13 hearts in the suit of hearts. So let's write that as a probability. So the probability of a heart is 13 out of 52, or more simply breaking down, it's 1 in 4. So let's have a look at this question. 2 fair die are thrown together and the scores are added together. And in part A we're asked to draw the two-way table. So here it is done for us. This is the first dice and all of the outcomes that it has, and here's the second dice. So when they said the results are added together, basically if the first throw is a 1 and the second throw is a 1, then the outcome is 2. If the first throw is a 2 and the second throw is a 2, the outcome is 4, and so on. Okay, so you're adding the outcomes of the dice being thrown. Now we're asked to find the various probabilities of these events occurring. So first of all is the probability of a 7, the probability that it's less than 5, the probability that it's greater than 5, the probability that it's even or divisible by 3, or even and divisible by 3. Well, first of all, we need to find out how many outcomes do we actually have. What is our total number of outcomes? Well, we know that our total number of outcomes is 6 times 6, which is 36. Now, there's 2 ways we can do this. We can do the multiplying, okay, basic principles of counting, or we can literally add all of these up. It's up to you whichever way you would prefer, but generally you use the combination rule. Now we recall that when we want the probability of an event happening, we put the number of desirable outcomes over the total number of outcomes. So for this question, our total number of outcomes is going to be 36. Well, first up we have part 1, and part 1 says that the probability of a 7. Well, the probability that it's 7 is equal to, well, if we highlight all the 7s, we've got 1, 2, 3, 4, 5, 6. So that means we have a 6 in 36 chance, and that breaks down into 1/6. And remember, we always give the probability in its simplest form. Now let's have a look at the probability that it is less than 5. So probability less than 5. Well, the probability of that is any number that's less than 5. Well, let's highlight the numbers that are less than 5. We've got 4, 2 3s and a 2. So that gives me 6 possible outcomes that are less than 5. So that means it's, again, 6 out of 36, which breaks down into 1/6. Now let's have a look that the probability is greater than 5. Well, very simply, if 6 out of the 36 outcomes are less than 5, that means that there's 30 outcomes that are 5 or greater. So it's 30 out of 36, which is going to leave me with 5/6. And that's our probability there. Now let's have a look at the probability of when it's even or divisible by 3, or when it's even and divisible by 3. So for part 4, highlight and try pick out all of the outcomes that are either even numbers or they're divisible by 3. So let's have a look at the ones that are even. So let's highlight all the even numbers. Well, we've got 2, 4, 6, 8, 10, and 12. And if we look at all of the ones, they're the even numbers, and then we highlight the ones that are divisible by 3. Well, divisible by 3 is 3. Then we've got 9. And we also have 12. So that leaves us with a total of 24 outcomes that are highlighted. So this leaves us with a 24 over 36, which very simply breaks down to 2/3. And now let's see if we can find any even and divisible by 3. Well, it's even and it's divisible by 3 means that it has to be both. It has to be an even number and it must divide by 3. So that actually narrows down our outcomes. So if we circle them instead, so if we want it to be even and divided by 3, so straight away we know it's going to be 6, because 6 is an even number and it has a factor of 3. And we also know that 12 is an even number and it has a factor of 3. So what that leaves us with then is a total of 6 outcomes. So for part 5, it must be even and divisible. So that only leaves us with 6 in 36. Which is 1/3. And if we look, 2/3 and 1/3 makes one full table. So we know that our outcomes are correct. Parts 4 and 5 of this question require a little bit of thinking. And we're going to look now into the and or rule. And what does that mean when we're talking about probability? See how you go with these questions now and complete them as a task.